Hi, in this video, I will be showing you problem number 3 and 4 from the worksheet on chapter 9 for the intermediate algebra class. Graph the parabola y equal to x minus 2 the whole square plus 1. So we will recognize this equation x minus 2 the whole square plus 1 in the standard equation of the parabola. The standard form of an equation of a parabola is y equal to a times x minus h the whole square plus k. If a is positive, the parabola would be open upward. If a less than 0, it will be open downward. H comma k, h and k will be the point of vertex. So in our problem, if you identify the given equation with the standard one, a equal to 1 here, so the coefficient in front of x minus 2 the whole square, there is nothing, that means it's assumed 1. It's positive, so the parabola is on an open upward kind. The vertex is 2, 1. So the vertex is 2, 1. So when we graph this, so we found out 1 point on the graph. We have to find out at least minimum 5 points, 4 remaining points on the graph in order to do a decent graph. So we are going to create a table. So when we choose the points, even though we can choose any point for x coordinate, we will choose 2 points to the left of the vertex 2, 1 and 2 points to the right of the vertex 2, 1. So we'll create a table like that. So in the table, we will have x, y equal to x minus 2 the whole square plus 1. We are going to input x and we are going to find out what y is. And then we are going to pair the x and y to make a point. Then we start off with the vertex which we already know. So 2. So if you plug in 2 in the place of x, we have 2 minus 2 the whole square plus 1, which will become 1. Now we are going to pair the x and y, so which will become 2, 1. So we are going to pick 2 points to the left of 2 and 2 points to the right of 2. So let's say we have 2 here. We need to pick 2 points to the left of 2. So for that, I'm going to pick 1 and 0 and 2 points to the right, which is 3 and 4. So we have to always give the table the increasing values of x. These are all x values. So we are going to start off with 0, 1, 2 is already there, then 3 and 4. So 0, 1, then 3, 4. It's always better to have 2 points to the left of the vertex and 2 points to the right of the vertex. Now we will compute the values here. So when we plug in 0 and we plug in 0 into x here, in this equation of y, we get 0 minus 2 the whole square plus 1, that will be a 5. So if we combine the ordered pair x and y, it is 0, 5, we get 1 point. Then same way you get substitute x equal to 1. So x equal to 1 minus 2 the whole square plus 1. If you simplify that, you get the value 2 for y. So if you pair 1 and 2, you get the ordered pair 1, 2. Then for 3, it's 3 minus 2 the whole square plus 1. You get 2. So 3, 2 is an ordered pair. Plug in 4. So you get 4 minus 2 the whole square plus 1. That will give us 5. So now we have to pair the 4 and 5. So you get these points 0, 5, 1, 2, 2, 1, 3, 2, 4, 5, of which 2, 1 is the vertex we know. So we will plot these points on the graph, starting off with the vertex 2. Then we'll plot 0, 5, 0, 5, then 1, 2, 3, 2, 4, 5. So connect them by means of a smooth graph. We already know that it's an open upward parabola. So what is important here is to show the table and show the vertex clearly. And the table should clearly show that what points you have chosen to sketch the graph. Problem number 4. Graph the ellipse x plus 3 the whole square over 16 plus y plus 2 the whole square over 36 equal to 1. We'll compare this equation, this form of the circle, with the standard form of the circle with center at HK. So the standard form of a circle of the ellipse, standard form of the ellipse is x minus h the whole square over a square plus y minus k the whole square over b square equal to 1. Always a is considered more than b. Here the vertex or the center of this ellipse is going to be h comma k. So only in the parabola we use the word vertex. In ellipse and hyperbola we use the center. So here in this problem, in our problem, the center is equal to -3, -2. -3, -2. So this is obtained by setting x plus 3 equal to 0. The parenthesis involving x, if you set that to 0, you get x equal to -3. If you set the parenthesis involving y to 0, you get y equal to -2. So these two values determine the x coordinate and the y coordinate of the center. Here the bigger one, a square in this case is 36. So we usually consider a square, the bigger one as 36, then the smaller one as 16. So a is plus or minus 6, b is plus or minus 4. So as the bigger one is right under y, the graph is elongated about the line parallel to y-axis. So as the denominator of y is more, the ellipse is elongated along the y direction. So the major axis will be along a line parallel to y-axis. The minor axis is a line parallel to x-axis. So now we are going to start off with the point -3, -2. So -3, -2 is right here. We'll plot the center first, that is center. Then we have to go a units along the y direction. So because this number 36 is right under y, so we have to move 6 units upward along the y direction. Then we have to move 4 units along the x direction. So from the center, you move 6 units upward. So that will give us -3, 4. Then you move 6 units downward. That will be -3, -8. Then you move 4 units along the x direction. So it is 1, -2. Then you move 4 units to the left of the center. The 4 units is the b units. So that is going to be -7, -2. So thus we have all the points that are needed to sketch the ellipse. Connect them by means of a smooth graph. So important point here is for an ellipse problem, you should decide which denominator is higher. So if the x denominator is higher, the graph of the ellipse will be elongated along the x direction, horizontally. If the denominator of y, which is the case here, is more, then it is elongated along the y direction. Hope this video helps.